send tweet, and then we'll get started. Okay, all right. Good morning, good morning. I hope everyone had a good week. Cool. So actually, hold on. Let me get water. 1 minute. All right. See this chat message. Yeah, hydrate or dihydrate. All right. So last week we went deep into the Erc20 token standard, and I think we mainly spent time looking at like how basically optionality and features are built on top of the ERC20. Mainly looking at voting. Was there anything else? I think that was the main thing. This week we're gonna look into balances, and then briefly touch on approval allowance calls. Basically, see if we can put together a table that's like protocol and then infinite approval or approval per transaction, basically. See if we can categorize some of those for USDC. And then we're going to calculate rebases for stETH, which is probably going to be the most difficult part. I already spent an hour this morning looking into it just because I was like, I don't think I know this well enough. So that's why you see that there's already a bunch of tabs open. But we will get to that. And let me just put this away for now, and we'll come back to it. So the first part should be pretty easy. I think I said that you could use either transfers. There's like this transfer event table, or just going from base logs. First thing we need to do is get the contract for USDC. Did my Wi-Fi go out? No, we're good. All right. Let's see. Oh, lagging. All right. So we're gonna take the USDC contract, do new query. And we're gonna get logs where contract address equals this. Remember, you always want the lowercase version, otherwise it won't be found. Right. All right, and we need the transfer event. Let's just go here. Transfer, take the topic. Hopefully this should all be second nature to you now. So let's start with this. That's actually going to be a lot. Let's do it. Cancel. All right. So we have basically address from, address to, I believe. Yeah. So let's just take from. Oops. Oh, my brain. All right. Let's do topic 2. We only want the last 20 bytes of this, so we're going to go gets 18 decimals. Hold on. Actually, no. USDC's 9. 6. All right. We'll use 6. That looks right to me. Oops. Right. That's an address. All right. So I usually do this with CTEs for balances. So let's do received as. Group by 1. So this is all transfer events received. All right. And we need the other way around. We need step. And that should be. So topic 2, actually, hold on. Topic 2 was sender. So this should be topic 3. It's topic 2, group by. And then select all from received or left join spent s. Again, joining spent on received because you shouldn't. This is a good trick question. Is there any address that could have spent more than it received, or could have spent first? The answer is yes, but I'll give a moment. Let's see. All right, spent as on r.user equals s.user, and let's do r.all s dot must order by oh, I didn't sum. This will actually probably take like 20 seconds. And so summing this across all of logs is obviously going to be slow, right? So what Dune has nicely done for us in abstractions is there's an Erc20 table or schema, basically, right? So if you go to Ethereum, you find Erc20, you'll see there's a tokens table, which has like all of the main or like top addresses with the symbol and decimals, but there's also, more importantly, I actually don't know where their ERC20 transfer is. Transfer? Uh-oh. Alright, maybe that's not exposed. But there's a faster way to do this. Alright, so okay, if I wanted to finish this, I need r.amount minus coalesce s.amount 0, right? Because they could have spent 0 as balance. So that would give me the balances for using logs. But we can also use erc20 dot erc20 event transfer. All right. So yeah, let me open a new query for this while this runs. All right, so you can see that in this table, it's like nicely decoded from to value already. And it's in the same kind of schema format as like all the other auto-generated tables, right? So this exists for ERC721 as well. But if we now did balances here, this would be a lot faster. All right, so with received as, and it'd be a lot faster because it's only transfer events versus every event on Ethereum. So I want 2 as user some value. And remember it's 6 decimals. Left join spent s on r dot user equals s dot user. And everything else is the same. So I can just take this, pop it on over, and you'll see this runs much, much faster. Or it should. I'm actually surprised it's taking so long. Because I know, let's see. Just pasting that in there. This is Q6. Because I have like a all balances query that used to run pretty quick. Hold on, let's see. Yeah, like this query runs literally like right away. And yeah, if you want to search up this query, you can either search by this or copy the link here. But this one is just like all of your ERC20 balances, and the only difference is I'm not filtering on. Oh, of course it's going to be faster. I'm only filtering on one from address. This is getting all of your token balances, right? So if I wanted to look at like I wonder if you can search up Vitalik. Okay, I don't think you can. Here, let me just look at the last person who transferred USDC. From this poor person that we're using as an example. Okay, they only hold USDC. They don't hold anything else. Wow, I'm actually really surprised it's taking so long. But I guess USDC has a lot of transfers, so that's not too surprising. Uh-oh. Why is this? Okay, I saved it. But that is how you get balances for USDC. I'm trying to think if there's a way to make it faster. Maybe we'll just try this on the new engine and see if it's faster. All right. So let's do this. Let's take a new query. Let's go to V2. Oh, there are balances tables in V2. Hold on. Are these filled. Oh, all right. We will not be using the V2 engine. The query line's a little too long right now. Well, it looks like there's already a balances table in V2. So it's kind of cheating, but you could use this. And the indexing should be faster on V2, so you could rewrite this just using, like, let's see, where were we doing this? So instead of ERC20 dot, ERC20 would be ERC20 dot event or use on V2. Wow, there's 92 queries in the queue. Okay. Well, we can't see the results, but you're just gonna have to trust me that this works. And here, we can just let this run in the background, and I'll work on some other stuff. So approvals before transfer calls. I think the easiest way to do this is we need essentially 3 steps. We need get approval calls and get amount approved. Check for only approval calls on addresses in Ethereum.contracts namespace. Get table with schema, name, namespace, approval approach. All right, where approval approach is either infinite or small. I think that's a good way to start. So I don't think there's an ERC20 approvals table. So we're going to need to do that manually. Here, let's see, open Zeppelin. Approve is address UN256. Or hold on. Address UN256. So the CAC. There's our approval emit. All right, so let's take all, so select all from Ethereum.logs where contract address equals, oops. Let's see, we want the USDC address again, just this one. And topic 1 equals this. Let me do limit 10 just to be sure. Oh. Alright, let's cancel this one. The queue is definitely, we're not making it out of that queue. I need this. Alright, so we have this. Just to be sure, let's check the transaction hash. Alright, yeah, that looks right. So let's do left join. Or actually, no, just a join. So this is an inner join on ERC20, no, Ethereum.contracts. C on L.contract Oh no, I can't do that. I need to add another join. Join Ethereum.transactions. Transaction.2 equals, yeah, that's fine. Transaction.2 equals c.contract address. Right, so let's do L dot. And then let's do L dot data. L dot transaction hash. And then C dot contract address doesn't exist. Maybe it's just C dot address. All right, so we have the transaction hash and we have namespace. Okay, yeah, transaction 2 doesn't work because I'm being dumb. We need to, all right, going over approvals again, right? So approving is you're approving someone to spend, right? And you're calling the USDC contract to spend. You can't have an approval called through like an internal call because it has to be like message.sender, I believe. And message.sender means it has to be the signer of the transaction passing it along. Yeah, I guess you could do a multi-call, but anyways. So we actually don't want to join by the transaction. We want to just check the address of spender here. And that is topic 2 here, which should be topic 3 in our case. So let's get rid of this. And we want substring topic 3. And we don't just the address, right? All right, now we're getting somewhere. Let's take. I think there's a couple ways of doing this, but I'm just gonna take average size. And remember, this is USDC, so let's just do this. And then let's do c.namespace, c.name, c.address. So let's start with this. All right, so if we group by 1, 2, 3, order by 4, send it. So this should give us, again, we want only approvals to contracts. Another approach here would have been row number and get just last value. That might actually be faster for us in this case. But let's do like. So there's some difficulty here of like figuring out if they're doing like infinite or not. Because I can't just do like case when like approval size is bigger than some amount. Because some people just transfer ungodly amounts of value on chain. So something that would be good to check, and this is like the extra logic you want to do, is basically seeing like after approval. So like right now we're getting approvals to contracts, right? We would probably also want to like join transfer to a contract and get average. Sorry. And get spend by user, which is topic 2. Okay, average is going to take way too long. Maybe we just do last. I think that's going to be faster. So let's do row numbers over. So this is a window function. We're partitioning by. I think we just partition by address. Order by event block event index. Right. Wow, that one's still running. Okay. Probably should have chosen a different token. What other query do I have running? All right, we're not going to do that one. Index, transaction index. All right. And transaction. Oh, it worked. All right. So now we can see actually the contracts, the addresses of approvals. And like a lot of the approvals are like basically like infinite size so that you never have to approve them again. I have no idea why these approvals are negative. That's weird. How in the world? Anyways. Do I have a logical error here? No, this should be fun. So like I would have just done something that's like if like we do case when is greater than like to the 50, I would say. Then infinite else transaction. That's probably gonna take a few minutes to run again. So this was Web3 practice question 6. So let that run, but I think basically every protocol does infinite again because like it's bad UX to approve basically every time you want to do something. If you approve 100, so if you approve 100 and spend 20, does that mean you have 80 remaining to spend, or you can spend 100 at a time? That's a good question. It means that if you approve 100 and then spend 20, there is only 80 left. So it actually decreases the allowance, right? So a good way of seeing this is if I go to the actual contract and I look at transfer from, it's actually, there's this function here that's spend allowance that actually is called before transfer, right? And the reason why for that is so like basically it checks that this balance exists to spend, right? So I can take a look and say spend allowance, and all it does is basically change the approved to be like, this changes the approved amount to now be um, whatever the allowance was subtracted by the amount you're spending. All right, so we can see that in the contract. Yeah, okay, that's gonna take a minute. So that is that one. Okay, so now we're on to the mind melter. We've done balances. Let me just make sure I cover things. We've done balances. You could get top 100 holders basically just by adding an order by and a limit, right? Like we could just do limit 100. That's like the fastest way, I would say. Um, and oh, where is it? Yeah, so there's like functional differences that can be built on ERC20, right? Like the functional differences are stuff like vote delegations, or like flash minting or stuff like that, right? But there's also like I guess storage differences or like internal differences. That's not the right way of explaining it. Basically, like you can play with balances a lot more, right, than just like relying on minting, burning, and transferring to manipulate balances. Some good examples of this are like a lot of people have tried, or a lot of protocols have tried like token streaming before. So you have protocols like Sablier and Superfluid that essentially like you set a stream rate and then it calculates your balance based on like how many blocks you've passed, right? So if you're streaming like 0.0002 USDC per block, it just kind of keeps track of that until the other person like wants to spend it, and it basically moves the balance over, right? Interest rates for protocols like Compound and Aave work the same way, where there's kind of this like exponential average interest rate that's calculated as your like borrowing or deposit rate, and it's like that's multiplied by like the time number of blocks that have passed. And like Compound and Aave implemented in different ways, but like the math that they use is basically the same, I think. And then the last most fun one that we've seen is like rebasing tokens, right? So it's like there's some rule that basically inflates token supply. So like every single day, like if you put 2 tokens in, then the next day when there's a rebase, you might get like 0.01 tokens given to you. Right? So like everyone gets the same proportional increase in their held tokens. Right? This is popular for tokens like I think Synthetics and like Olympus DAO did it. But probably the one that's going to stick around the most, I hope, is staked ETH, right? And this is implemented by Lido. And the idea there being is like, if I staked ETH into Lido, then I have to get my rewards somehow, right? So I get a rebase basically with my like staked ETH rewards every day. And you might be asking, oh, does this mean that they send tokens to like all of the token holders once a day? And the answer is no. For staked ETH, in their case, they track using shares, right? So it's like the same concept you have with like Uniswap, where like if I deposit tokens into Uniswap, I get this like LP token back that represents like my shares in the protocol. And it's like it doesn't matter how much more liquidity is added or removed from the liquidity pool, like my shares of the pool don't change in like percentage terms, right? So it's like take that share concept and now add like a proportional increase every day to your shares, if that makes sense. Or sorry, that's not a good way of explaining it. It's not exactly to your shares, but like to the whole pool. So that's probably confusing, but oh, this query finished running. I wonder if there's any in here that are not infinite. Oh, we do have some. So, well, this depends on the threshold you set, but I'd say that's still infinite actually for 49. Anyways, for this question, you should probably play with the range. But all right, Lido, this is gonna be fun. I'm gonna try to explain this as clear as I can. So the way to calculate rebasing is actually not too complicated, right? You have like some base token that you're redeeming for, and then you have the token that represents your shares, right? So in Uniswap, you would have like ETH as like what you're like ETH USDC is what you're trying to redeem, and then you have like your LP tokens are your shares, right? Um, so you could kind of calculate how much token you're supposed to get, based off of fees, kind of from that, or not based off of fees, but based off the total pool. So in our case, for staked ETH, it's like how much total ether is in the contract divided by like how many total shares people hold, right? So you can kind of get an exchange rate of like, oh, if there's like 1,000 and like 200 um like ETH rewards total in the pool, but like the total deposited shares is like 1,000, then it's like okay, the rebase is like 200 over like it's at 200 extra, right? So it's like whatever 1,200 divided by 1,000 is, right? So that'd be like a 20% rebase. And that's like you can kind of think of that as like an exchange rate as well. That might be like an easier way to mentally format it. So basically, when I was looking at it, the way it works is like they use an Oracle system that tells basically the Lido contract, hey, today this is how much more ETH rewards we earned. And based on that, increase the max shares, like distribute fees to like the staking operators, but more importantly, increase like both the amount of ETH in the pool and the total shares of the pool, right? That probably doesn't really make much sense. So let's just like look into it, right? The contracts are easy to find, right? You can just search, like you can just search stETH, and you'll be able to find staked ETH, the one with the Lido symbol, right? It is a proxy, so like if you want to look at the actual implementation code, you have to go into the implementation address, and like we could do our typical like .deth.net, but in this case, the functions are a little more confusing, I would say, in terms of like what calls where, right? So like you have your base stETH like token, which is inherited, and they kind of explain in the contract here like how shares work, right? There's like shares that are actually tracked by address in here. Um, and so like there's transferring of shares on top of transferring of tokens, right? The same way that last week when we were looking at like, oh, if I'm transferring the compound token, my delegation is changed upon transfer. The shares is just transferred as well per transfer, right? So like yeah, I'm trying to find. Right, so like when transfer is called, transfer shares is also called, right? And again, this is important because otherwise, like if I swapped something in Uniswap and I have the tokens, but the shares weren't transferred, someone can still burn the shares for like the underlying ETH amount, but then I wouldn't be able to burn the token, right? If that makes sense. I think the best way to explain this. So I actually went and took the LidoDAO GitHub repo and put it into VS Code just because I needed to rely on the Solidity visual debugger or developer, right? So I needed this in this case, and all I did to use this tool, is once you have it downloaded and you've forked the repo, you just click graph instead of graph this. Remember, graph this is just the contract itself, but graph is like the whole repo. And I basically wanted to understand when like shares were created or burned, right? So I clicked on mint shares, and I can see, oh, this is called by the Lido contract, and it's called by handle Oracle report, right? And like this seems to be the main piece of logic that's like moving things around here. And I can also see that it's called by this fallback function, right? And a fallback is just like like let's say you call the Lido contract with a function that doesn't exist on the contract, like it checks the function signature and the function signature doesn't exist on the contract, then it actually looks for the fallback, right? So it's like, okay, last resort, like what do I do with this data, right? So like a fallback function basically always just handles. It handles the data based on what's being submitted. So it's like, okay, as long as like you're submitting some data within it, it doesn't matter what function signature or like input you use, right? And that calls submit, and submit has like basically this is a deposit function, right? I'm not going to go over this, but the main one we can see is like, okay, there's a handle Oracle report that's like minting these shares, right? So I would look through here and say, all right, what's happening in handle Oracle report? There's probably all of this wording that is more like contract pattern relevant than like actually relevant to the data stuff for us. But if you kind of just look through it, you can see, oh, there's some sort of rewards going to validators. There's some sort of fee happening. But I don't see where like mint is being called, right? So I have to kind of look through here and see, okay, it's actually distribute fee that's calling mint, right? So then if we go to distribute fee, then I can see they're explaining here what exactly is happening in the pool, right? And this is important. It's essentially saying, all right, there's some amount of fees, basically shares, right, that are going to the miners, or not the miners, the node operators, right? And what they have to calculate, or basically for the rebase to work, they have to add the amount of ETH that's now in the pool after like the rewards come out per day, and they have to mint the shares, mint new shares to the operators, because obviously like that's what they're earning, right? You're not minting new shares to the holders, right? So like if I have 500 shares, I'm not getting extra shares, but the total amount of ether in the pool goes up, so I am getting more shares, if that makes sense, right? Like if I held 100 shares and then Jackie held 100 shares and there's 20 ETH in the pool, and then this reward thing happens and 2 more ETH gets put in the pool, like now Jackie and I both have 11 ETH, right? But there's part of that's taken out into fees that goes to the miners, or the no, I shouldn't say miners because that doesn't technically exist. It's on ETH2, it's the validators. So like some amount of fee, which is, I actually don't know how much fee they take. That'd be a good thing to look into. But essentially, some amount of the fee goes to the node operators, and that's minted as new shares, right? So it's as if like, oh, Jackie and I both had 100 shares, but now this validator gets 10 shares. So our like percent ownership of the pool changed. So some amount of that new 2 ETH would end up going to the validator in terms of redemptions, but the rebase is still happening in terms of like we now get more ETH for the same amount of tokens we've put in, right? And essentially that's what's being calculated in Richard's query here, right? Where it's like, all right, I know that total shares changed, right? And that the total shares changed because that of the fees that were paid to the validators. And I know the post like total ether in the pool changed because that's like basically they push this once a day and tell them, hey, this is now basically how much ETH you're getting for one staked ETH, right? And it's like there's this is if you've looked around Twitter, you've seen like, oh, there's like a 7% discount factor, and it's like, yeah, you're getting 7% basically per ETH you put in over time. And like that's the APY that's calculated here. It's like, okay, if I now compare this rebase from like last year to this year, has like exchange rate of ETH to stETH kind of gone up, right? And so like this is like your actual ETH stETH redemption kind of balance, but it's like there's all this complications around like queuing and like liquidity in terms of like obviously you can't withdraw any ETH off of ETH2 right now because it's locked until the merge, right? So like this is like your real exchange rate, which obviously isn't going to match the exchange rate on like Curve because that's like liquid rate, right? But like this is what it should be if it was fully liquid, if that makes sense. So stake ETH is like a interesting case for rebasing. Olympus Styles implementation isn't too hard to understand. The interest rate ones are a lot more complex, and it's easier to use storage data, I think, for it. I'm not going to cover that this time because that's actually that'd take a while to cover, but hopefully that helps make rebasing make a little more sense. Again, the logic is just like you have some sort of shares you've put in once, and you're automatically accruing rewards based on either some oracle or some daily kind of like unlock. And you're essentially getting more and more of the token, right? And yeah, I'm trying to think if there's anything else important on that concept. I think that covers the important bits of it. If you're still confused, I would take more time and literally just like read this one portion, right? It's like you have to understand how like the fees are distributed when the oracle is called, and you have to understand like this first part of the code here of like how are shares mapping to balances. If you can understand those two, then you should be able to understand like, oh, okay, this is how they're paying out fees and increasing like your rebase rewards without actually transferring any tokens, right? Otherwise, it's like if they wanted to do like a full rebasing reward, then like they would have to have like another actually would they have to have another okay, this is where I'm like my expertise kind of stops. I was thinking, I was like, do they need another token to represent that? Actually, I don't think you do. Anyways, point being, hopefully the math here makes sense now. Technically, you don't need to know all of this to do this query, but I think it's good to understand this pattern because rebasing is used quite often. I would say in like a lot of kind of rewards protocols where there's like any sort of liquidity lockup, meaning like some sort of protocol where you deposit your tokens and can't withdraw them for some amount of time. Right, that's like kind of what staked Olympus is as well. And yeah, it's kind of used a lot for crazier financial incentives. because it's like, oh, the more that people lock, the more liquidity you lock, the more liquidity you have to generate revenue, and like the longer you have it locked, the longer you can generate revenue, so the more rewards you can distribute back to the holders, right? So it's like this kind of like flywheel effect, and that's why rebasing tokens are like fairly popular. Yeah, all right, I'm gonna end it there. I hope that is helpful.